Alright, hi guys, we're going to work through one of the examples from the PowerPoint, which I'll flick over to here and I'll go full screen so you guys can see what it looks like. So the question is to determine the interquartile range for the following data set: 12, 9, 4, 6, 5, 8, 9, 4, 10, and 2. So I've got the data set written down already here on my paper. And what I'm going to do is I'm going to work through, find the interquartile range, and I guess from there you can follow along with me or see how you go. Okay, what is this? I can wait. Alright, so first thing I have to do is find the median. To do that I have to put this data in order, so I'm going to do that first. Got 2, 4, 4, 5, 6, 8, 9, 9, 10, 12, 8, 9, 9, 10, 12. Hopefully I got that right. 2, 4, 4, 5, 6, 8, 9, 9, 10, 12. Good. Okay. So then from here, I got to find the quartiles. I got to find the median, then the median of the lower half, and the median of the upper half, and that'll be my quartiles. So to find the median, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, and to find the median, I'm looking for the nth plus 1 divided by 2 value. So whatever, how many numbers there are, plus 1 divided by 2 will tell me where my median is. So if I've got 10 plus 1 divided by 2, it tells me that it's at the 5.5th value, or halfway between the 5th and the 6th. So I have 1, 2, 3, 4, 5, 6. Halfway between 6 and 8 is 7. Okay? So I know my median is equal to 7. Now I've got to find my Q1, my Q3. Okay, so to find the Q1, I find the median of the lower half. Because I don't have a median value, I'm in between two values, we include this number here. If the median was, say, 6, I would only work from the numbers below it. So the median's not included if it's an actual value. If it's between two values, then you include both values either side. Okay, so we have 1, 2, 3, 4, 5. 5 values plus 1 divided by 2 to find our median of the lower half, which is what the Q1 is. Gives me 6 divided by 2, which is 3. So that's my third value, which is 4. And again, I'm going to find my third value of my upper half, which is 9. Okay, so I've got some data here now. And to find the interquartile range, I'm looking at the range between Q3 and Q1. So to find that simply, my IQR, or interquartile range, I do Q3 minus Q1, which equals 5. And that tells you how varied the middle 50% of the data is, which in this case is not very much. Okay. That was a very short example. I feel like I owe you guys a a longer example. Oh, standard deviation. Alright, so let me make this as clear as I can. Standard deviation, I will talk about it now, but you won't have to do this by hand in general maths. So it's important for you to understand what it is, so you can describe it properly, but you won't have to do this. So I'm not going to do it on paper because it's a complicated process. So if you look at the screen in relation to where my face is, I think it's below, but anyway, the desktop screen with the PowerPoint, if you were trying to find standard deviation, what you would do is you need to first find the mean, which is denoted by this X with like a little line above it. Symbol, it looks like this. Okay, so in this case, the mean is all those values on the screen added up, divided by how many there are, which is 8. So the mean is 14.5. Now this table looks a little bit complicated, so I'm going to explain it a column at a time. So X is simply a data point, or a score. So we have one for each of those individual points that were at the top. we've got a 14, a 14, a 13, a 15, a 16, a 13, a 14, and a 17. Okay, so that's our data points. The second column, or the middle column, is the value of that data point minus the mean. Okay, and that will give you either a negative or a positive value. So we've got those values there. So we've got negative 0.5, negative 0.5. We've got a few negative 1.5s. Nothing too exciting though. Now next is something that, how do I put this? We're trying to find out how varied each data point is away from the mean, right? So we do something here where we square each of those values to take away the positives and the negatives. So they're all positive values, because a negative and a negative together is a positive. Positive and a positive is obviously a positive. So we're taking away those negative values by squaring it, sort of normalizing the spread of data. And that's our third column, which is that. And that gives us a total of 14 when we add up all those squared differences, is what they're officially referred to as. Now, if you look over, there's an equation there, and I'm going to explain it to you because I know that this is a little bit scary looking, but it basically says S, or the standard deviation, is equal to the square root of, and then it looks like there's sort of like an E sort of shape. It looks like this. I actually stuffed that up, didn't I? Yes. Got little things like that. So that means sum of. So all of them added up. So we're saying that it's the square root of all of those squared differences added up, divided by how many values they were, minus 1. Okay. So that equals 14 divided by 8 minus 1, because there were 8 values. Gives you 14 over 7, which is 2. So our standard deviation is the square root of 2. Okay. And I won't bore you with what it means, but it's essentially to do with a standard deviation. It has to do with a bell curve, which we'll do a bit later on. And it's got to do with how many values lie within a certain point of the mean, either higher or above. That's basically it. But I will show you how to do it on the CAS in a separate video. So I would recommend watching that one. I'll actually go through it a little bit better. This one I sort of just rushed because, like I said, you don't need to work this out by hand. Okay, cheers.